Okay, hi, and welcome to another installment of Math Basics with Mr. Besh. Again, we're going to be talking about compound area, but since the last time we added another shape in our tool belt here, and that is a circle. Okay, so the first thing you need to do is you look at this, and it's describing a hockey rink, right? And then on the left and the right side, you notice that there are curves, and all the shapes we talked about, there's only one shape that actually has curves, and that is the circle. Now, when you think about this and you break this problem down, the first thing that you're going to notice is that the circle-ish shape on the right, notice I said circle-ish, not even really a word, but look, you're going to get my point here. This guy right over here on the left and this guy right over here on the right, you're going to say, yeah, I know what these guys are. Each of these guys is referred to as a semicircle. And what a semicircle is a half a circle, right? That's what we have, semicircles. So now when you take the two semicircles and you put them together, now what you have is you have a full-blown circle. So when you're doing a problem like this in compound area, one of the things that you want to definitely do is take the shapes that you see inside the big shape and jot them and or sketch them down separately in a notebook along the side. So the first thing I'm going to do here is I'm going to take the semicircle over here that was on the left and the semicircle over here on the right, take both of these, put them together, and now what I have is I have one circle. Then, since I'm finding area, I'm going to write down the math formula for the area of a circle, which is pi times the radius times the radius. Remember, in circles, radius is essentially everything. Now, they don't tell me in the problem specifically what the radius is, but they do tell me from one end of the circle to the other is 80. So now what I need to know is I need to know half of that. And now what that means is that my radius of my circle is going to be half of 80, which comes out to be 40. So then when I apply my math formula and I use my calculator here, when I take 3.14 times 40, what I end up getting is the area of my circle, and that's 5,024. Now that's my first piece. The second piece of this puzzle is you have to figure out the area of the rectangle in the middle. So now here it is, going to do my rectangle. Now you want to hear something funny? The hardest part about this is identifying one of the measurements. One measurement I know right off the bat for the rectangle is going to be 80. That's easy to see over here. But the length of this guy, a lot of students have trouble with this. What you got to do is you got to work with this. You know this right here is 200 from one end to the other. But now what you also need to realize is not just does the radius here go from the center and go up over here. This can go from here to here too. This is also going to be 40. So now the extension on these semicircles go out 40 and 40. Remember, the whole deal, the whole way across this circle, the diameter is 80. So that means my radius is 40 and 40. So what I got to do is I got to shave 40 not once but twice from this, take 40 away from each of these. And when I do so, I get my missing measurement right there. I get my length of that rectangle. And now when I'm calculating the area of a rectangle, write down the formula for that. It's just simply the length times the width. So then all I got to do is take 120 multiplied by 80 here. And this comes out to be 9,600. And then all I have to do is take the two areas of each of the regions and add them together. And when I take these guys and I add them together, my final answer to this problem is 14,624. Now remember, not worried really right now about the labels. I just want to make sure that you get this down pat and that you're able to identify the shapes inside the complex shape and able to match up and use these mathematical formulas. So this is the compound area of our first example here with integrating circles. And that's basically that. I hope you found this video both helpful and informative.